Okay, let's continue our discussion of investment making decisions. And remember, I've said it before, can't hurt to say it again. We're looking at this situation from the viewpoint of an outside investor looking in at the company to decide whether or not to invest in the company's capital. Remember, capital on the balance sheet is 5 accounts: long-term debt, preferred stock, common stock, paid-in capital, retained earnings. Those 5 accounts we're calling capital. Now, of those 5 accounts, there are 4 sources of capital. Long-term debt, and remember, we're only going to concentrate on corporate bonds. Preferred stock, then there's common stock and paid-in capital, which are 2 parts of the same thing. Right? Remember, par value goes into the common stock account. Everything else goes into paid-in capital. And then there's retained earnings. Now, 5 accounts, 4 sources of capital, but 3 providers of capital. And those 3 providers of capital are the bondholders who buy the company's corporate bonds, give the company cash with the expectation of getting a return. Then there are the preferred stockholders who buy the company's preferred stock, give the company cash, pardon me, with the expectation of getting a return. The third provider of capital is the common stockholders. They buy the common stock, and that cash gets divided between the common stock account and the retained earnings account. I'm sorry, paid-in capital account. Sorry. The common stockholders buy the stock, give the company cash. That cash is divided between common stock and paid-in capital. And the common stockholders are the ones who allow the company to retain part of the net income. And that shows on the balance sheet as retained earnings. So long-term debt comes from the bondholders. Preferred stock from the preferred stockholders. Common stock, paid-in capital, and retained earnings, all from the common stockholders. So what we've been doing is going through each of those providers of capital and talking about how you could make an investment decision, pardon me, on whether or not to invest in each of those types of capital. Every time, thus far, every time we've done it the same way. We've used the discounted cash flow method, which means we have to know the expected future cash flows. We have to know the investor's required rate of return, and then we put them together to find the present value. And that present value is what we call value that we compare to price. And then every time we'll take the next step and calculate the expected return. For bonds, that expected return had a special name, yield to maturity. But preferred stock also had an expected return. And that we compared to the required return. Okay? If price is greater than value, then if price is, excuse me, let me turn it the other way. If value is less than price, then expected return is less than required return, and we don't invest. If value and price are equal, then expected return and required return are equal, we do invest. If value is greater than price, then expected return is greater than required return, and we do invest. Those are the same rules, the same methods we used for both bonds and for preferred stock. Okay, I want to kind of bring us almost to the close of this discussion by doing that exact same thing now for common stock. All right, We're going to use the same handout as last time. We're going to use the same method, the same comparisons, everything. All right, like I said, finance isn't hard. Finance is repetitive because we do the same thing over and over. So let me share the handout. It's the same one as we used with preferred stock. Okay, I'll make it a little bigger so you can maybe see it more easily. There we go. All right. Like I said, discounted cash flow method. Here's the discounted cash flow method. We need to know the expected future cash flows. You need to know the investor's required rate of return. And then we find the present value. All right, for now at least, I'm going to give you the investor's required return. I'll tell you what it is. Before we're done this semester, we'll talk about how to estimate it for ourselves, but for now, I'll just give it to you. We know how to find present value, so every time the new thing was how to find the expected future cash flows. All right, find the expected future cash flows. I'll give you the required return, put them together and find present value. Now, we started with bonds because that was the most straightforward for finding the expected future cash flows. All right, let me see. Let me make this a little better. Once we knew these 4 characteristics about bonds, then we knew everything about their expected future cash flows. Right? Then we talked about what might happen to cause the cash flows to be different from what we expected. Default, callable bonds, convertible bonds, those sorts of things. But once you know these 4, you know what to expect. Okay, then we took this same process a step further to talk about preferred stock. And here on page 3 of the handout is the little table we looked at. Right, for corporate bonds, always have these 4 characteristics: par value, coupon rate, payment schedule, maturity date. Preferred stock had all 4 of those except maturity date. Preferred stock has a par value, a dividend rate, coupon rate, dividend rate, it's still a percentage, and a payment schedule, but no maturity date. Right? Once we knew those 3 things, then we knew what to expect for preferred stock. Right? Except we talked about this idea that if preferred stock was cumulative, then the company can skip dividends, but they have to make them up later. And they can't pay dividends to common stock until they have made them up. So you can think of it as the preferred stockholders will receive the dividends. It just, the timing may be different from what you expected. All right. And so how did we get around this idea, this problem, this characteristic of having no maturity date, of not knowing how long those dividends were going to last? Well, we assumed that they lasted forever. Right? Nice thing about that assumption is that it then lets us rely on calculus and treat preferred stock as a constant perpetuity. I think that we talked about constant perpetuities in learning module 4, I believe, right? When we were still introducing the time value of money, constant perpetuities. And since we're taking the present value of all these dividends, the present values are getting smaller and smaller and smaller. not the dividends, they stay the same. The present values are getting smaller and smaller and smaller until they're practically zero, until they approach zero, until the present value approaches zero. So that then when we add up all those present values, at some point, we're just adding plus zero, plus zero, plus zero. So does the stream of dividends have to really literally last forever? Well, not really. Not really. Conceptually, as long as they last long enough for their present value to approach zero, then it's a reasonable estimate of value. How long is that? Well, that depends on how big the dividends are, depends on what your required return is, those sorts of things. So we just make that assumption, rely on a little, pardon me, a little calculus, and find the value. All of which then brings us to common stock. And on page 6 of the handout is where we start talking about common stock. And you can see I have the same little table. Whoops, there we go. The same little table, only now including corporate bonds, preferred stock, and common stock. Bonds had all 4 of those characteristics: par, coupon, payment schedule, maturity date. We knew what to expect. Preferred has par, dividend rate, payment schedule, but no maturity date. We know what to expect, and as long as we're willing to assume they last for a long time or forever, then we get a value. But now we come to common stock. And almost everything that we knew about bonds is missing from common stock. Common stock has a par value. Remember, we've talked about that several times, that when the company sells new stock, common stock, the money they receive gets divided between par value into the common stock account and everything else into the paid-in capital account. So par value we've dealt with. But common stock has no set dividend rate. It has no set payment schedule, and it seriously has no set maturity date. Par value determines how the money is accounted for, but it has nothing to do with the dividends, the cash flows, nothing. So everything that we knew about bonds and almost everything we knew about preferred stock is missing. We do not know what common dividends will be. We cannot know what common dividends will be because there's no rule. There are no rules. There are no, pardon me, characteristics that determine it. Why is that? Why is it that common stock is such a free-for-all? Well, I believe we talked about it earlier when we were talking about the, pardon me, the balance sheet and the income statement, and the idea that when we're talking about net income on the income statement, bondholders get paid first, right? If you're looking at the income statement and you start with sales and then cost of goods sold and work your way down, you'll come to interest expense. That interest expense includes the coupon payments for the bonds. So bondholders are the first ones to get paid out of net income, out of sales on the way to net income. All right. Next, preferred stockholders get paid. And if you continue down the income statement, you'll come to net income. And usually there's a line right below it that says dividends paid or cash dividends paid. preferred stock is in there, but preferred stock gets paid next. So that what do common stockholders get? Well, common stockholders get what's left over. They get what's left over after bondholders are paid, and after preferred stockholders are paid, and after the company has retained a certain amount of earnings. Then what's left goes to common stockholders. Right? Which may be a lot, it might be nothing. It might be different from period to period. It might be, like I said, it might be nothing at all. There are companies that never pay a dividend. Common dividend. Other companies that pay exactly the same common dividend, and others that let it fluctuate up and down. My point is that we cannot know what the dividends are going to be for common stock. So that if we're going to use the discounted cash flow method, and therefore have to know the expected future cash flows, then we're going to have to make assumptions. We're going to have to assume something. Okay? If we're going to use the discounted cash flow method, then we must know the expected future cash flows. Well, with common stock, it's impossible to know the expected future cash flows. So we're going to assume. And we're going to make two assumptions. Happily, both of these assumptions both refer back to Learning Module 4. Our first assumption we're going to go with is that the common dividends are constant. We're going to assume that the common dividends are constant amount on a constant schedule that lasts forever. That's assumption one. Now, that's not a very good assumption because it's very unlikely that common dividends will actually be paid that way. So we'll go on to assumption 2 and make it a little bit better and say, okay, we're going to recognize that the dividends are not going to last forever. So let's assume that the dividends are always growing and always growing by the same amount. But they stay on a constant schedule and they last forever. Now, that's still not a very good assumption, but it's better than the first one. At least assumption 2 recognizes that common dividends can change. Now, once we've made those dividends, then it's a really simple matter to refer back to where we came from, back to Learning Module 4, I think it was, and talk about dividends as a constant perpetuity and dividends as a growing perpetuity. And we've dealt with both of those things before. Okay, well, let's see how this works. And we should be able to go through it pretty fast because we've already been through constant perpetuities and growing perpetuities. Right, so let's start with assumption 1, constant perpetuity. What does that mean? Constant perpetuity. Well, it essentially means, we haven't called it that, but essentially it means an annuity lasting forever. Right? Calling it an annuity, what does that imply? Well, that implies that the cash flows, in this case, dividends, are always in the same amount, and they're always paid on the same schedule, every 6 months, every quarter, every year. They're always the same amount, and they're always paid on the same schedule, and we'll assume that they last forever. Constant perpetuity. Right? Now, not only did we talk about constant perpetuities before, back when we were learning about the time value of money, but we also just finished talking about them when we dealt with preferred stock, because preferred stock, we assumed, was a constant perpetuity. Right? Finance is not hard. Finance is repetitive. We're doing the same thing now for the third time. Right? So that means, assuming a constant perpetuity, that just means that our value, remember it's V with a 0 next to it, V for value, 0 for now or the beginning of the timeline, is simply the cash flow, that constant cash flow, that constant dividend, divided by the required rate of return. And as long as you're careful and make sure that the compounding agrees, that if they're semi-annual dividends, you use a semi-annual rate and so on. Very, very simple. Right? So here's an example, a quick example. Right? Quick because we've done this before. Right? We're assuming we're trying to find, pardon me, the value of common stock. The common stock is paying a semi-annual dividend of $50 a share. So that semi-annual cash flow or dividend is 50. Right? We're assuming that that continues into the foreseeable future or forever. Excuse me. And our required rate of return is 8% a year compounded semi-annually. Right? So we got all we need. Right? Super simple timeline. Right? Every period is half a year or semi-annual. Every dividend is $50. There's the ... that tells us it goes on forever. The ellipsis that tells us it goes on forever. Plug it into our formula. We get 50 over 4%. Why 4% and not 8%? Semi-annual. And a value of $1,250. Right? So that value is $1,250 a share based on the assumption that the dividends are a constant perpetuity, always the same time schedule forever, and on that 8% a year required rate of return. Now, based on that, should we invest? Well, let's see. The current market price is $1,100 a share. So in this example, value is greater than price, right? We know that because the value is $1,250, which is greater than the price of $1,100. So we should invest. Right. Hopefully by now this seems really, really familiar. Okay. Now, as always, we go that extra step to find the expected return. With bonds, that expected return was the yield to maturity. Right? With stock, we just call it expected return. It doesn't have a special name. Right? And the formula for that expected return is the cash flow or the dividend divided by the current market price. Right? P for price, 0 for now or the beginning of the timeline, the current market price. In this example, the cash flow or the dividend is $50 every 6 months. The current price is $1,100, right? That's price and not value, right? P for price, not V for value. Price gives me 4.5%, but that, of course, is semi-annual. How do you know that it's semi-annual? Well, because it's based on semi-annual dividends. So it's a semi-annual return. I don't want semi-annual. That doesn't mean anything. Let's turn it into an annual return by multiplying by 2. Right? Semi-annual multiply by 2. Quarterly multiply by 4. Monthly multiply by 12, or so on, so on, so on. All right, based on that, let's see. Should we invest? Well, in this case, the expected return is greater than the required return. All right, we know the expected return is 9%, and that's greater than our 8% required return. So we invest. And now, like I've said, these are two ways of doing the same thing: value compared to price, expected return compared to required return. Two ways of saying the same thing, so they will always give you the same decision. You will not find a situation where value compared to price says yes, and expected return compared to required return says no. You won't do that. They will always give you the same decision. Okay, so what that tells us is that assumption 1, the constant perpetuity, is essentially assuming that common stock behaves like preferred stock. So we do the same thing as we did with preferred stock. Go refer back to time value, to present value, the constant perpetuity, and done. Okay, but what about assumption 2? Assumption 2, a growing perpetuity, right? It's a marginally better assumption than 1. At least, as I said before, at least it recognizes that the dividend can change, but it assumes that it's always changing by the same percentage. Right? That one's even a little hard to take, isn't it? Okay, but if we can make that assumption, if we can assume that the dividends are growing and always by the same percentage, and that they stay on the same schedule and last forever, then we can look back to who now is our friend, calculus, and find the value or the total of all those present values. And that formula is here, value. The value of a growing perpetuity is CF1, or it could be div1, dividend 1, CF1. Again, that subscript refers to the timeline. Now, 1 is the next one, the upcoming one, the one we have not received yet, but will happen at the end of the next period. Right? That's important. In order for this to work, in order for the calculus to work, we always have to use the upcoming dividend and not anything previous, only the upcoming one. Okay? And we divide that by R, the required rate of return, minus G, the growth rate. Now, if you remember back when we were first learning about growing perpetuities, I gave you this image, this example of my sisters and me at the top of the up escalator trying to work our way down. And the reason we made it to the bottom of the escalator is because we were walking down faster than it was going up. Same idea here. In order for the calculus to work, we have to be discounting it using the required rate of return faster than the dividends are growing at the growth rate. And that tells us that this formula works if and only if, that's what IFF stands for. It's math shorthand for if and only if R is greater than G. Now, what if it's not? What if R is not greater than G? We'll come back to that before we're done. Right? Now, if you take a second and compare this formula for a growing perpetuity to the formula for a constant perpetuity, they're really the same. Yeah, and I can hear you thinking, no, they're not. This one has a 1, this one has G. Yeah, except think about the constant perpetuity. Why did I not put that little 1 subscript there? Why did I not make a big deal about how it has to be the upcoming dividend and nothing past? Well, the reason I didn't make that big deal is because they were all the same. It doesn't matter if it's the next one or the last one or the 20th one or what, they're all the same. Okay? And what about the G? Right? Constant perpetuity, sorry, cash flow over R. What happened to the G? Well, in the constant perpetuity, what's the growth rate? Well, they're not growing, so the growth rate is 0. So the formula is R minus 0. Right? All of which is to try and make the point that these really aren't different formulas. It's the same formula, but different conditions. You could use this formula for the constant perpetuity as long as you remembered that it didn't matter which dividend and growth was 0. All right, so we'll use this simple formula in an example. All right, now notice in this example, dividends are semi-annual, and the next or the upcoming dividend is forecast to be $75 a share. And in this example, I use D instead of CF, but it's the same idea. So that means D1 is $75. Now, that's important. Remember that in the growing perpetuity, it's important that what we use is not the last dividend, the previous dividend, but it's the next, the upcoming dividend. And that's what I said, the next or upcoming dividend, right? And I call it D1 because that 1 on the timeline, excuse me, is the next one. Okay? Right? Our growth rate is 6% a year, compounded semi-annually, and our required return is 7% a year. I'm going to go over that in a second and just do the calculation. Right, so value, cash flow, or dividend 1, 75. Right, they said the upcoming dividend is 75. Right, divide that by R minus G. Well, what happened? I thought R was 7%. Yes, but I have to divide it by 2 for semi-annual, so I get 3.5%. And the growth rate is 6% a year, but only 3% semi-annually. Put that together and I get a value of 15,000. Now that seems really, really big for a share of common stock, but bear with me. Okay, now the problem said somewhere, oops, I've lost it, sorry. Oh, there it is. There it is. Let the market price be 17,500 a share. So in this case, value, 15,000, is less than price, 17,500. Do not invest. Right? Same thing we've done over and over. Only now we're assuming that those dividends are growing. Okay, and we always take that one step further by looking the expected return. The formula for the expected return is this. The formula for the expected return is the dividend divided by the price, all of that plus G. Right? In other words, you take the dividend, the upcoming dividend divided by price, and then you add G. Okay, and in this case, pardon me, the upcoming dividend is 75. The price is 17,500, and notice price and not value. Price, P0 price, 75 over price, all of that plus the 3% semi-annual growth rate. And I get 3.43%, but of course, that 3.43% is semi-annual. Right, we know that because the dividends we're using are semi-annual. The growth rate we're using is semi-annual. So this expected return is semi-annual. To make it annual, you multiply by 2, and we get an expected return of 6.86%. Expected return is less than our required return. Not very much, I'll grant you, but still less. That 6.86 is less than our 7. Do not invest. We compared value to price, and it said no. We compared expected return to required return. It also said no. All right. Now, one other thing that I threw in here is that, yes, we know the next dividend is 75, but what about the one after that? Well, that's easy enough to find, right? We start with 75 and we use that 3% semi-annual growth rate, pardon me, and we get 77.25. That's easy. It's a simple future value calculation. Right? Equals future value. The first item is the rate, and that's our growth rate, 3%. The number of periods, well, that's 1 to 2, 1 period. It's not an annuity, so we don't use that payment. Just put a 0 there for a placeholder. And the present value is 75. Close it, hit enter, and you get 77.25, and that's the 75 plus 3% growth. It's a simple future value calculation. Right? What about the one after that? Well, it's the same thing, only now we're going to find it for 2 periods. Right? It's still the 3%. Still the 0, still the 75, but now instead of 1 period, it's 2, and I get the 79.57. Right? Do it again for 3 periods, 81.95, and so on and so on and so on. Right? What's the point of that? Well, the point of that is just to be able to figure what the dividends are expected to be. And it's a simple future value calculation. Okay. All right. Let's see. I'm going to skip that one. I'm going to go here. Example number 3. It's still a growing perpetuity. Right? We're assuming semi-annual dividends, but now notice that what I've given you is not the upcoming dividend, not the next one, not the upcoming one, but the most recent past dividend. Right? In other words, what this 55 is D0. It's not the next one. It's not the upcoming one. It's the previous one. Right? It's not D1 or CF1. It's D0. But the formula does not want D0. The formula doesn't work if you use D0. It has to be D1. So if, like in the previous example, I give you D1, well, great, I'll just plug it in the formula and get an answer. If in this situation, right, I throw you a curve and give you D0 instead of D1, then we have to turn the previous dividend, D0, into the upcoming dividend, D1, and that is a simple future value calculation. Right, and there it is. Right, all I did was take D0, that 55, and turn it into D1 by taking its future value. The rate, 2%. Where in the world did that come from? Well, the growth rate is 4% a year. So that's 2% semi-annually. So there it is, 2%. One period from D0 to D1, that's one period on the timeline, one. It's not an annuity, so we just put in 0 for the payment, 55 for the present value, calculate it, and I get 5610. What I want in the formula is not 55, the previous one, but 5610, the upcoming one. And to turn one into the other is just a one period future value calculation. Right? So here's the timeline, and you can see there's the 5610. If I do the same calculation, pardon me, only for 2 periods, then I get 5722, and there it is. 3 periods, I get 5837. There it is, and so on and so on and so on. Okay, so now we've turned D0 into D1. We can plug it right into the formula. There it is, 5610. Divide it by the required rate of return minus the growth rate, both of them adjusted for semi-annual. Right? The required return is 10% a year, but 5% semi-annually. Growth is 4% a year, but only 2% semi-annually. I do the calculation and I get a value of 1,870. But our market price is 1,750. So in this example, the value, 1,870, is greater than our price, 1,750, so we do invest. Value greater than price, invest. Right? Take it the next step to find the expected return. Right? That upcoming dividend divided by price. Then all of that plus G. Our dividend was 5610. Our price, not value, our price is 1750. All of that plus G, semi-annual growth, gives me 5.2%. But for the millionth time, that's a semi-annual growth, or expected return. Multiply by 2 to get an annual one. So we have an expected return of 10.4, which is greater than our required return of 10. So we do invest. Okay. All right. Not too difficult, I hope. With the constant perpetuity, that's really very straightforward. All right, you just take that constant dividend, divide it by the required return, and you've got the value. Right? To find the expected return, you just take that constant dividend and divide it by the price. You get the return. Remember to adjust that return to make it annual, but there it is. All right. With the growing perpetuity, you just have to be really careful about which dividend you plug in. It always has to be the next one or the upcoming one. If the problem gives you the next one, D1 or CF1, no problem. Just plug it in and use the formula. Excuse me. But maybe the problem gives you not the next one, but the previous one, D0 or CF0. And in that case, you have to use a 1-period future value calculation to turn D0 into D1 using the growth rate. Once you've done that, then it's a simple matter to plug it in and get your answers. Okay. One thing I want to point out, a couple things actually I want to point out before we go. Right. The first one is this formula for the growing perpetuity. Right. Notice here's the formula. And in this formula for the expected return, right, in this formula for the expected return, you do a calculation, CF over P, and then after you've done that, you add G. All right, I take whatever the next dividend is divided by the price, and then after I've done that division, then I add G. Right? Anybody care to guess what the most frequent error is in doing this, in using this formula? Right? And I know this because I've been teaching this material forever. The mistake that people make is they forget to add G. Right? First, you find the next dividend, okay, and then you divide it by price and you get a number and say, okay, that's it, and move on. Don't do that. First, you have to add G. That's the mistake that happens more often than anything else in this growing perpetuity, right? Doing the calculation and forgetting to add G. So be careful. Don't forget G. Right. The other thing you might be wondering is, what about this if and only if thing? Right. If and only if R, the required return, the discount rate, the amount that we're taking away from those future dividends is greater than the growth rate, the amount that those future dividends are getting bigger and bigger. As long as R is greater than G, we are taking away more than they're growing. And as a result, the present values get smaller and smaller and smaller until they approach 0, and we can use the calculus. Right? Another way to think about it, as long as R is greater than G, my sisters and I make it to the bottom of the escalator because we're going down the steps faster than they're going up. Now, what if R is less than G? What if the amount we're discounting is less than the amount that they're growing? Well, what that means is that the present values will not be getting smaller and smaller, so that they will not present value eventually approach 0, so that instead of getting a simple answer, the answer is infinitely large. All right, so if R is less than G, the formula doesn't work anymore. It doesn't make sense anymore. My sisters and I can't get to the bottom of the escalator. It keeps pushing us up to the top. Right? The other way to think about it is if R is less than G, then when we subtract them, we get a negative number, which gives us a negative value, which doesn't make sense. right? Negative value. That means the company would pay us to take their stock. Well, it doesn't make sense. Doesn't make sense anymore. This works as long as you're willing to make these assumptions, and as long as R is greater than G. Okay, so you might be wondering, this common stock valuation, it relies on a whole lot of assumptions, doesn't it? And it relies on assumptions that we know are not true, right? We know that the dividends will not be a constant forever, right? In the same way, we know that the dividends are not going to grow by exactly the same percentage forever. We know these things. So what use is it to depend on these assumptions that we know are not true to give us a value? Well, it's a fair question. It's a fair question, and it's a question that drove one of the most important developments in all of finance. And that's something called the capital asset pricing model. No, we're not going to do it now. We're not going to talk about it now. We'll wait on that. It's the capital asset pricing model. And what that model does is take an entirely different approach to common stock. Right? Up to this point, we've been using the discounted cash flow method, and we've had to know the cash flows and the required return and the present value. Capital asset pricing model takes a completely different view. And instead of trying to forecast the future, it depends on measuring risk. Ah, there it is. I told you we'd get back to it. It depends upon measuring risk and finding a way to find the value or the price of risk, and then uses that to give us the way to make a decision. Right, so what we've done up to this point is use that discounted cash flow method 3 times. Bonds, preferred stock, common stock. Really 4 if you count that there were 2 assumptions under common stock. Okay, now what we'll do in the future is we're going to come back to this idea of common stock and instead talk about the capital asset pricing model. Okay, as always, let me know if you're having trouble. If you have any questions, I'll get back to you as soon as I can. Thanks.